Hi guys, I am Dr. Nanda Balaji. Today we are discuss about the topic of Bohr magneton. Ever wondered how we measure the magnetic moment of an electron? The answer lies in a fundamental unit of magnetism called the Bohr magneton. The Bohr magneton is a physical constant that represents the smallest unit of magnetic moment associated with an electron's orbital or spin motion. It is essential in atomic and quantum physics for describing the magnetic behavior of electrons. Like as formula of mu b it's equal to EFL divided by 2me. E is a elementary charge like as 1.602 into 10 to the power of minus 19 coulomb. FL it's a reduced Planck's constant h by 2 pi. Me mass of the electron 9.109 into 10 to the power of minus 31 kilogram. Quantum mechanics behind Bohr magneton. Electrons act like tiny magnets. Their magnetism comes from spinning in place, spin moving around the nucleus orbit. Bohr magneton likes this motion to magnetism. It is a bridge between quantum physics and magnetism used to explain how atoms behave in magnetic field like in the Zeeman effect. In electrons behave like tiny magnetic due to two types orbital motion around the nucleus and spin motion on their own axis both contribute to a property called the magnetic moment, which is basically a measure to how strong a tiny magnet is. But how do we quantify this? And then the introduction of Bohr magnetron mu b is equal to EFL divided by 2 me. This is where the Bohr magneton comes in. It's a physical constant that represents the magnetic moment of an electron due to this orbital or spin motion, whereas E is the charge of the electron like as Planck's constant HL, these like that. Application of Bohr magneton used in MRI scans to study the human body, helps in ESR to detect materials, explain how atoms behave in magnetic fields, helps study magnetic materials used in quantum computers to control tiny magnetic bytes like as qubits. In like as origin and historical significance of Bohr magneton, the Bohr magneton was proposed in 1913 by Niels Bohr during the development of the Bohr model of the hydrogen atom. It helped physicists explain how atoms respond to magnetic field, especially in phenomena like Zeeman effect, where spectral lines split due to magnetic influences. Role in atomic and molecular physics like as electron spin and magnetism. Electron spin creates a tiny magnetic field called magnetic moments. Zeeman effect. The Bohr magneton helps explain the splitting of atomic spectral lines in a magnetic field. The magneton became the standard unit to express the magnetic moment of electrons, atoms, and even ions. Atomic structure study helps in Atomic structure studies helps in understanding how electrons behave inside atoms, and then like as molecular magnetism useful in analyzing molecules with magnetic properties. In experimental determination, Bohr magnetrons, Sternglum experiment showed that electrons have spin and a magnetic moment. Magnetic field deflections, electrons deflect in a magnetic field based on their magnetic moment. Measured magnetic moment used to calculate the value of the Bohr magneton. Confirmed quantum theory proved that magnetism at atomic level follows quantum rules. Future prospects and summary of the Bohr magneton will continue to play a major role in future technologies like quantum computing, where controlling the spin of electrons is key to building powerful qubits. It also supports to develop of nanomagnetic device and advanced sensor in material sciences. As a fundamental concept in modern physics, the Bohr magneton helps scientists understand how atoms and electrons behave in magnetic field. In summary, this tiny magnetic unit connects the worlds of quantum mechanics and real world applications, making it essential in both research and technology. Thank you, guys. Thank you.